So, good morning, everyone. My name's Paul Deakin, and I am a systems engineer on the F5 federal team. I've worked there for 12 or 13 years now, but today I'm honored to host a panel discussion on advanced cloud cybersecurity intelligence through collaboration. So, we're hosting representatives from MITRE and the Cloud Security Alliance, and they're going to discuss their groundbreaking partnership through the Cloud Security Adversarial Vectors, Exploits and Threats Working Group, known as CAVEaT. So I'd like to introduce Alex Kaluza from the Cloud Security Alliance, Mari Spina from MITRE, and Kurt Seifried, also from the Cloud Security Alliance. So Alex, why don't you tell us a little bit about yourself?
Thanks, Paul. Yeah, I've been with CSA around 6 years, and I'm involved with the data security group, one of the AI organizational responsibility working group, and different threats and like the top threats group I've kind of been involved with. So it's kind of being with this CAVEaT group was kind of a natural fit with all those technologies and kind of discussion ideas kind of together. And it's been really kind of exciting to kind of be with this collaborative group with this and be very experimental and trying something new and trying to be stay ahead of the curve here.
Excellent. And how about you, Marie?
Oh, thanks, Paul. So I'm Mari Spina, and I've been at MITRE for 10 years, and I lead the cloud security capability area. And I've been involved in CSA probably since I came to MITRE. And one of the reasons was that I wanted to make sure that the voice of the US government was represented in some of the CSA research. And I noticed they had quite an international coverage and following, and they were making real headway in cloud security capabilities, standards, controls, and research. Really being on the leading edge of research. So I want to be involved in that, and so I'm very, very proud and excited to be a part of anything having to do with Cloud Security Alliance.
Okay. Well, welcome to the panel discussion today. And how about you, Kurt?
Hi, thanks. My name's Kurt Seifried. Started out in open source security actually about 30 years ago, and then became a security analyst for about over a decade. And then I actually ended up going to Red Hat and being the first cloud security hire on the product security team. And so essentially I was involved with the first generation of cloud products, especially the ones that were based on open source, moving into, the more commercial space. And I also joined the CSA actually a little bit before Red Hat, about 15 or 16 years ago. And so, yeah, basically the focus of my work has been research around security, especially cloud security and now AI security. And my involvement with CAVEaT, the thing I really like is the fact that we can actually give people really actionable workarounds and mitigations and not just vaguely generic advice like you should firewall it or only open trusted links in your email. But we can actually give people real hard, like click this and click that to fix it, which is what people need.
Hey, Marie, why don't you tell us a little bit about the history of CAVEaT and how it came to be?
CAVEaT was as an experimental thing at MITRE where we wanted to kind of go beyond the attack model to focus specifically on cloud service related threats and how those threats would be mitigated, specifically using the cloud service related commands and widgets and configurations. But we wanted to touch what attack doesn't touch, and that's sort of a predictive threat base. And so what we knew was that in order to really get to sort of forecasting adversarial actions, we really needed to bring in industry, and we needed to almost apply kind of a crowdsourcing approach so that we could get industry leaders from the cloud service providers, from practitioners, and from kind of the core that the Cloud Security Alliance represents, from that user, that member base, to get them to really help us, right? It wasn't something that MITRE could do on its own. It just needed too many inputs. And so we ran the idea by Kurt and the CSA leadership about forming a working group and having this working group, evolve the threat base that was sort of prototyped. And so we feel it was very, very successful. And this really, and I'm very excited about the directions that we're going. And Alex is going to give you a rendition of where we're going with this. But we are really forging ahead right now in predictive modeling and incorporating AI to help us do it. And one of the real sort of golden nuggets here is that in the end, if we can better predict the threats and vulnerabilities, and we can use adversary emulation with predictive threat modeling, we're going to stand a much better chance of finding our own 0 days before the adversary does. And to me, that's really my main objective. And I'm very, very happy that this working group is going and that we're making such headway.
Excellent. Do you think it makes it easier for the practitioner, or maybe that will come to light with Kurt's demonstration?
Well, I think you'll see in Kurt's demonstration that we really are enabling the practitioner. And the notion of a co-pilot for defensive cyber ops is not new today, or although it's relatively new in the industry. AI enabling the defender. But I think what Kurt will show you is actually quite revolutionary. And we're all learning about it. Kurt's sort of driving us there and teaching us as we go. So thank you for that.
So, hey, Alex, why don't you describe the CAVEaT working group?
Yeah, sure. Well, across of all the CSA working groups, it's really one of the newer groups. I mean, amongst many, but at least it's been around for a couple of years now. But as far as, some of the maturity of these other groups, in comparison. But basically, as we're saying, it is this joint collaboration between CSA and MITRE as the core, with having others in the industry. Of course, Paul being with F5, just getting that collaborative kind of outlook from others that are experts in the industry. But having that CSA MITRE foundation. Yeah, we talked about kind of the industry needs of having emerging threats. This publication that came out, I believe, November 2023. This is the main kind of overview of the whole CAVEaT kind of project and idea and kind of purpose of this, and almost laying out how things are gonna, how all the next, these different tools and publications from here, how they all can relate back to the main mission of early threat detection and guidance and that kind of, and mitigation capabilities. So so far we've had that really has been the main publication. There was also a CSA MITRE, tabletop exercise that was done at, I believe, a few different in-person sessions and events. So that was kind of cool to see real active kind of participation in a tabletop exercise. I believe we actually did that at our main September conference as well. So yeah. Also, there's been a few different presentations that Mari has presented at different kind of important things, the Army Cyber Summit, and this Midnight Blizzard attack on Microsoft's analysis. So a few, I believe last year, definitely one of the more prolific things to kind of to analyze. Those are just kind of some of the examples of things that we've kind of done. Right now we're really in this experimental phase where we're just trying to figure out what is the best way to kind of put all this together and make something useful out of it. So our initial phase here was to kind of working with, the tools that we had at the time, which if you're looking back, not really very long ago, but say 6 months, 9 months ago, or a year ago, with ChatGPT kind of exploding and allowing all these new capabilities, and then having GPTs that are custom built off of that to kind of useful however you need, however you want to, with the idea being to explore the CAVEaT data sets and connect to others. And kind of as we developed that and we saw iterations of that to kind of going along, we realized, and we also saw ChatGPT and other AIs getting more features and more advanced. So a big key feature here was ChatGPT having the web search enabled. kind of changed the game, or at least our main, how we were looking at things, as opposed to having our own large databases that we're uploading and then querying and searching through. Now we have web search, which can then pick and choose all of that kind of data that's already kind of available. And so we're just trying to figure out the best way to work with that. And so that's kind of our existing chatbot that, you can kind of talk to and work with. And we actually did have someone on our with our CAVEaT group who has, kind of been beta testing a lot with it and using it in his own research for his own schooling, but also his new job that he started with recently. So it was kind of cool to hear some direct results from that. It's kind of still helping us shape that. And that, I think this one still has potential even on its own. And there's kind of being its own ChatGPT bot. But the idea of what we're looking at now and what Kurt will kind of get into and explain, very much, it's been an experimental phase. I was just saying, we're really just kind of grinding through this and brainstorming and throwing ideas out there and seeing what makes sense. But I mean, I think that's what happens when you're just trying to develop these combinations of AI tools in a new process. So, for now, we're calling it the CAVEaT Cyber Threat Intelligence, AI tool. I'm sure we'll have a different name at some point. Here's kind of just an example of guard duty malware protection, an example creation that, later we could, her, I'm sure we'll touch on. But that's really where we're at as far as the group. So, it's been somewhat light at the moment because just trying to figure out what we want to have to present and build out this prototype. Because once we have something that we can know the exact process and how it all functions and we see it, then we can start getting it out there to talking about it in front of our group and getting people to mess around with it, try it, and then also get into our process where they're actually building out these CTI, our CTI repository, which we'll get into next year.
Hey, Mari, why don't you describe the vision of the CAVEaT AI tools portal workflow here?
Okay, yeah, thank you so much. It's very, very exciting. So it all sort of started as Kurt's brainchild, and so much of this is Kurt's brainchild, because you might say I was kicking and screaming while he was dragging us into the AI world and teaching us along the way. It all started with the CAVEaT ChatBot, and Kurt showed us how easy it was to build. And quite frankly, it was successful right off the get-go. I asked it a few questions. I know I had a real kind of a difficult one. I said, I can't remember, give us the code to mitigate against this threat in Amazon, S3 or something. And it was spot on. I ran it back through MITRE SMEs, and I said, what do you guys see? And the answer was really, hey, it's really good. It's right on. There's nothing really wrong with it, but it's maybe missing the nuances of, a veteran in the field. And to me, that was a good sign because it was so new. People were so skeptical. And if I could get the junior engineer to operate at an intermediate level, that's good. That's really good for industry. So I said, we'll take it. And then Kurt just went in some other direction, like beyond that, without me knowing where he was going. And he came up with this notion of, and really it kind of spawns this new idea of AI pipelining. And the question is, and industry is going to be wrestling with this now, we're wrestling with it now all over, how do I integrate AI into my workflow? How do I use AI to be better at what I do? And so Alex and I said, okay, Alex, we gotta sort of give Kurt the framework and the guardrails. We gotta tell him, what we want. So let's develop the workflow. So Alex and I worked on this workflow, and let me just go through it real quick. The idea was, there might be an event in industry that triggers an engineer, a cloud security engineer, to say, oh God, something I'm worried about. I need to know what a mitigation would be. I want to implement something now. And the idea is that they would then go to the CSA CAVEaT tool portal and get the AI tooling to help them to understand the threat, potentially build the threat technique, and then develop the mitigations for their particular issue. And then publish that so that it's useful for everybody, right? Because, usually when one engineer asks, it's not, others are going to need it. And we very quickly said, okay, well, we're dealing with LLMs, large language models. We're going to have to give people some template, some guidance on how to build the prompt, right? Because you've got to ask and if things are to be repeatable, you kind of got to have repeatable prompt engineering, right? So prompt engineering is like a new science. How do I talk to the AI? How do I converse with it? And what's interesting is you find it, and Kurt had me doing this. I talk to it like it's a friend or a family member. And I'll say things like, I'm upset with you because you didn't give me what I asked, and you know what I want. And so pretty soon, you develop this relationship, but it's an important thing for prompt engineering. So we want to provide those templates and tools. The other thing is, and you see this blue sort of layered model, multiple AI backends, web search, structured analysis, MCP, agentic prompts, LibreChat. What this is an attempt to illustrate what really is emerging is the new AI stack, right? The AI application stack. And the question is, how do we layer in these AI tools or these AI connectors or these tool connectors that help us to integrate capabilities to achieve an objective in a workflow? And so Kurt's going to go over what that toolkit is and how this stack looks. But again, two emerging things, right? LLMs, how do you talk to them? AI pipelining, how do you integrate it in? And the new application stack for AI. So in all this, we want to give folks the tools to generate both the TTP, what is the tactic, technique, and procedure that the adversary would use, how is it remediated, and what would be the actual code-based mitigations that you'd implement for your cloud service. We then want the practitioner to be able to generate that prompt and have the results basically auto-generate using AI and be produced in a context that could be usable for the rest of the world in the CAVEaT framework, so to speak. And it's very much looks like a TAC, but it has further details for cloud service stuff, cloud service related mitigations. And then of course we want all this to go into a repo. We're kind of calling it the CAVEaT CTI repo at the moment. And when the user believes that it's, you might say, ready to publish, they would do a pull request so that, requesting that it be included in the library and in the repository. We've got it working or we plan to have it working so that the review committee gets the emails that says, hey, there's a new CAVEaT TTP to go look at. And, please review and approve or reject or comment, this kind of thing. At some point, then the workflow is going to process, the committee agrees, and it becomes part of the repository. The key here is that we want to use the stick syntax so that it's readable within the industry by folks. And we know that there are some SOC operators that definitely use it. And so it's immediately shareable in that syntax and then available in the repo. And so in the end, this is really how we expect to build that database and to have that database sort of be auto-populating, you might say, crowdsourced driven, and maybe even event driven, where there's some important industry event that folks want to hurry up and go get support on. So I think we've come up with a great workflow or a great pipeline, and I'm very, very excited about where we're going and the results that we're getting because they're really good. You're going to see when Kurt goes over it, but I think that's all I got on that.
So I have a couple of questions. Maybe these are questions for Kurt, but how can we prevent hallucinations? How do we handle hallucinations? And also, if you're using it, how do you prevent data leakage? Like if I'm a company and I've got a problem, how do I use the tool without providing it enough information, or how do I provide enough information where I'm not giving away private information? And I know Kurt's now going to demonstrate the tool, and maybe he can answer those questions along the way.
To be clear, we'll be providing the tool both as a web interface that we run, because the thing I've run into is there's a lot of people who can't install stuff on their corporate laptop. Like, they're just not allowed to, especially when it's like, I want to install Docker and run arbitrary containers. And of course, there's security people, once they're done laughing, are going to say no. But we are also going to be providing all of this in a way that you can then run locally. So for example, using your own account in Claude Desktop, or if you're really paranoid, running your own local LLM with your own stack 100% on a air-gapped laptop for the sake of argument. Because fundamentally, it's the pipeline, the workflow, the prompts, that's kind of the value, if you will. Actually running it, like, yeah, you can run this stuff on a laptop now, or with a $20 a month Claude account. That's one of the beauties I find of AI is, all these AIs are $20 a month. Like, it's ridiculously cheap. And the other thing, well, and back to the other slide, is every one of those individual components currently works with the AI. We're now in the process of like gluing it and engineering it all together. And so a perfect example of that is the Model Context Protocol started existing November 25th of last year. And in 4 months, at the time of this recording, it's taken off. LibreChat is beginning to have support. They've been working on it for about 2 weeks, and so probably by the time you're watching this, the support should be working reliably. Like, essentially, they've got it working, but not reliably. So when I do the demo, I'll be using Claude Desktop, because Claude Desktop obviously has very mature Model Context Protocol support, because Anthropic invented it. And also, this is then a demo that you can just run it locally with your own Claude account. And literally, the web interface would just be basically the exact same thing, but with a web interface on a site that we run and operate. And part of what's fascinating too is, like, for example, the hallucinations you talk about, and that is a big problem. There's a couple of things you can do to prevent hallucinations. You can ground the AI, have it look at data, blah blah blah. And to be honest, you should do all of that, but none of that actually matters, because ultimately, no matter what you do, you should be doing quality control of your products, right? Like, you look at any manufacturing company, and they will have done process optimization out the wazoo, and they will still do Six Sigma or whatever quality control system, ISO 9001, to ensure that they're not shipping lawnmowers that randomly catch fire or something. And so no matter how much you do to ensure that the system is good and high quality and produces good outputs, you still need to look at the outputs and make sure that they're reasonably correct and well formed and so on. And part of the beauty now is well, you can have AI do that. And a perfect example is we built a system to generate multiple choice questions for a training course. And we had the AI doing 16 dimensions of analysis on the question, plus doing like a simulated test taking experience with the question, which would have been horrifically expensive to get a human to do, right? It was a couple hours of work for each question. And we had the AI do this and got great results. And the AI actually, failed a bunch of questions. Like, one of the metrics was, is there only one correct answer? Because sometimes there would be kind of two correct answers. And, well, that's not really fair. And the AI catches this stuff, like, assuming you ask it and tell it to do this. So part of the secret to, I think, the success I've had with these AI systems is I spend about half my time quality controlling the output and trying to make sure it's good. Because the AI will, I want to say the AI will make mistakes, but I also quite often ask it for the wrong thing. So with this, Model Context Protocol is basically a fancy way of having the AI be able to use tools, and the tools basically tell the AI what they can do, which makes it really easy for the AI to use. So part of the challenge we've had with building tools to support CAVEaT is that the fundamental capabilities of AI keep getting better. So, like, I was worried about the context size, and we had to very carefully manage how much data we gave the AI. We could only do 8,000 tokens, and then it got full and gave up. And now, we're talking 200,000 tokens. So we can basically shove a copy of War and Peace in there and not worry about it. And then, for example, tying the tools together was very difficult and troublesome and time consuming. And then Model Context Protocols dropped, and all of a sudden, your Claude Desktop can just talk to your file system and talk to GitHub, and it takes, minutes to set up. So we started out with essentially a traditional chatbot with a prompt. And again, a great example here is it was in the summer, right, that ChatGPT got web search. And so all of a sudden we went from having to like cut and paste stuff on a web page into the chatbot and saying, like, can you please look at this and analyze it, to now just like, hey, go search for X and like figure it out. And it does. And then we realized we could just put that in the prompt. And basically the prompt, for example, says, make sure you have up-to-date data by doing web search. And it does it most of the time. So I'll do it. Essentially, this is the old obsolete version. So we'll just do a quick demo of it. So this is basically the air quotes original chatbot. And it's essentially, it's not obsolete, but it, for example, can't, talk to your file system, and can't talk to GitHub, but it can still get good results. So for example, So I asked the AI, can you please search Hacker News for any recent discussions of new cloud security threats and summarize the top 2 or 3? And as you can see, it's found hidden weaknesses in cloud-based multi-factor authentication, centralized risk, privacy concerns, compliance challenges. Okay. Abuse of dangling resources on cloud platforms. Ah, yes, this is a new one. So this is something somebody did a paper on it even. Okay, so this is a perfect example. Okay, so this is interesting. So I'll just basically ask the AI, can you analyze and then cut and paste the abuse of dangling resources and literally just say, look at it from a CAVEaT stick-centric viewpoint. It's kind of amazing to me that you can basically just gibber at the AI and 9 times out of 10 it'll figure out what you want and do the right thing. So as you can see, a recent study of Archive, the academic paper hosting site, talked about dangling cloud resources. So what these are is, for example, you have an S3 bucket that you stop using but you don't delete it, and so it's just kind of sitting there. And some of these offer, file uploads, for example. So attackers are looking for these and using them to upload and spread malware, for example. So if anybody's old enough to remember FTP, file transfer protocol sites, again, this was a common thing we had in the late 90s. So everything old is new again, and we just reinvent it and put cloud in front of it. Obviously, yeah, detection challenges. Finding this would be difficult because, it's like an old resource that you're probably ignoring because you got rid of it. And so it comes up essentially with breaking it down into a couple of different aspects, and even provides mapping with MITRE attack, right? So acquire infrastructure cloud accounts, traffic hijacking via abandoned cloud resources, spear phishing via service impersonation, and then it can write up a sticks entry. And one of the lovely things is, originally when I started doing this, I thought, I'm going to have a lot of prompt explaining what the sticks format is, the security threat interchange format, and we're going to have examples. And it turns out the AI knows what it is and can just read and write it accurately. And so that's the other thing. The AI is a lot more capable than a lot of people would guess, and you really do need to just start experimenting with it and asking it, and it'll probably surprise you in a good way. So here we go. And you'll notice here it's covering the top 3 kind of global cloud providers, and that is because our prompt specifically says, anytime you're looking at solutions or problems, consider all 3. Because to put it bluntly, if there's a security problem with a service in Google Cloud, probably Azure and AWS have the similar problem, because they've basically all, it's like cars. They all need seatbelts. They all need airbags, as it turns out. And so here, for example, monitor DNS requests for unexpected changes, right? Track IP usage, blah, blah, blah. And so it talks about mitigation techniques even. And again, we had our prompt specifically say, what are ways to specifically, fix that thing? But are there things you can do to, mitigate it and prevent it in future? And so, for example, enabling IP retention policies, and don't give up those IP addresses and rotate them. You're going to pay a little bit extra, but you're not going to have to worry about losing your IPs. And in GCP, apparently there's a thing called Cloud DNS Resource Records Locking, which I did not know about. And that's the other thing is, Amazon Web Services, the last time I checked, which was last summer, has 1,120 major services in their documentation. And some of those services are small and simple, like say Amazon Transcribe, which transcribes audio. And some of them are like Amazon EC2, which has a lot of sub-services as well. So there's over 1,100 services at Amazon, and basically the same for Azure and Google. And so just even knowing that services exist, let alone how do I securely configure them, we've now gone past what humans can do. We need automation and AI to help us, because simply put, this is beyond human scale. Even if you had a full-time team, you will still miss things. And so, for example, it talks about some next steps. And so at this point, you could literally just say, produce me a sticks formatted file, and then, cut and paste it, save it into the GitHub repo, and do a pull request and submit it. But like I said, this is the old sort of air quotes obsolete version. If we go to Claude Desktop, you can see here, so I've already kind of got it ready. We're basically going to tell it, can you read the file /users/Kurt/GitHub/working group CAVEaT? That's a public GitHub repo in the Cloud Security Alliance working group repo at GitHub, and we'll give the links later. And basically just go read the prompt, and then also read the README file for the CTI repo, the Cloud Threat Intelligence repo with the CAVEaT data, and say okay when you have. So essentially, I'm asking it to read the prompts and just not do anything yet. You know, sometimes it basically forgets that it can do things like web search, and then you have to remind it like you can read files. Or fetch a document, and as you can see now, it's reading the files. I've read both of them, and typically when you ask it to read a file, it'll also give a quick summary of what it is. Okay, so I'm going to give it an instruction basically. I want you to web search for dangling resource pointers and summarize them in STIX attack pattern format. And so it's going to ask to do a web search, and it's going to do a web search. And once it's done doing the web search, oh, and the other nice thing is it will often do multiple web searches and hone in on what it really wants, much like a human would. So again, this is all work a human could do, but it's going to take the human more time. And, you know, this in theory can also be fully automated. So as you can see here, also I told it to give it to me in the attack pattern format. So this is, well, the attack pattern. And as you can see here, yep, that is a STIX format file. Yeah, and we got our kind of cloud platforms listed, attack vectors, elastic IP takeover. Yeah, as we saw before, those elastic IP addresses, right? Once you release them, an attacker can grab them and start looking at what traffic is coming their way. And then, yeah, here we go, remediation. And this is the part I love the most, is it will give you like the actual command that you need in its entirety. Sorry, let me make that bigger. So it'll give you the command that you need, and you can also have it give you the API command and, you know, the other things.
This is all happening on the local system, right? You're using Claude Desktop here.
Yeah, this is, so the way Claude Desktop works is basically all the MCPs are running locally on my system, and the only thing going to Claude obviously is the AI related requests. But then, for example, Claude replies with, oh, you know, you want me to web search for something, I want you to do a web search. And like literally the web search command it sends back to my desktop is I want 10 results and search for this. And then my desktop, you know, goes to Brave web search and sends it that query and says I want 10 results. And as you can see, there's the results with their little titles and synopsis. And then it sends that to Claude, and Claude thinks about it, and then, you know, basically does a new web search with kind of honing in on the answer better. And so, like I said, we'll basically be offering this so people can run it locally on their system if they want. We'll also have a web interface running LibreChat, which will essentially be doing the exact same thing, just running on our web server so that people don't have to install anything on their laptop or whatever.
Okay, that's excellent. I really want to say thank you to all the panelists today and all the audience that that watched the show. But you can reach back out to the folks and get in contact via the shared information on the conference website or via LinkedIn. But thanks to everybody who joined today, and also to our distinguished panelists.